With all the parts modeled, it's time to assemble them into a working mechanism. So we've got the base part, and then on that base part goes the arm, and the arm has got the larger diameter hole in it, so it's going to fit down right around the larger part of the pin. On top of that goes the drive wheel, which fits around the smaller part of the pin, and we want to set it up so that the drive wheel and the arm move together when this operates at a mechanism. Then over on the right hand side, the cross part fits over to the smaller pin. Now, because this is a mechanism, the parts that are going to move in the mechanism need to be assembled with pin constraints rather than with coincident constraints. If you assembled everything with coincident constraints, it wouldn't move as a mechanism. So let me show you just a few tips for how to handle the constraints as you assemble these parts. I've opened up a new assembly. It's all blank, so we want to assemble the base part first. So I'll click on the base part and then open, and that comes into view, and it's completely unconstrained now. So it can move and rotate anywhere in 6 degrees of freedom. So for this one, I want to set it up with the default constraints, which anchors it onto the reference plane, and then click OK. The next part that goes in is the arm part, so I've already brought it into the assembly window, and then kind of move it over to this side, and I'm going to want this hole to go around this section of the left-hand pin that's coming out. So I'll go up to the top on the component placement settings and click on the user defined menu, and then select a pin constraint. And then down on the bottom is telling me to select the axis or edge on one part, so I'm going to select the inside of the hole, that surface on the inside of the hole, and then I'm going to select the outer surface of the pin. I don't want to select this surface, I don't want this surface, I want the outer surface of the pin. Okay, so that is going to align the pin with the hole. Now if I go under placement, I'll see I'm in the connection 1 pin axis. Now it's asking for the translation. So what that's asking is this can move in and out. How close to the base do I want it to be? And I want it to sit right down against the base. So for that, I'm going to move it out where I can see it. I'm going to turn off the spin center because it just makes it easier to rotate things. And I'm going to select the underside of the arm, and then rotate back and select the base. And that came up as a coincident type for the translation. So that means that it's all sitting down there on the base and ready to go, so I can click OK. Now to check to see that I got things right, I can go up to the model and click on the drag components. And it's got a little window over on the right. I want to keep it on this one, which is point drag. It's telling me to select one item, so I'm going to select the crank with a single click, and then as I move the mouse around, I can move the crank around. So that tells me that it's assembled properly with a pin connection. Next up is the drive wheel. So we want to assemble the drive wheel onto this pin that's coming up out of the base, again with a pin mechanism, with a pin constraint. And then for the translation, put the bottom side of the drive wheel flat against the top side of the arm. So that would result in this drive wheel being able to spin on its pin, which is what we want. However, there's one additional constraint that we want to set up, and that's to have the drive wheel move with the crank arm. So let's think about how to do that. Okay, I skipped ahead a few steps in the assembly. I went ahead and assembled the drive wheel as a pin connection onto the axis of the pin, and then I set the top surface of the drive wheel to be coincident with the very top surface of the pin. So now it's all there and it's able to spin, but the problem is that it can spin independently of the crank. So the next thing I want to do is to set its position so it and the crank turn together. So for that, I can right click on the main window and then add a set, which adds a new constraint set. So here I want it to be a rigid constraint set, and then I'm going to have it be coincident. So one of the ways to do this is to actually, instead I'm going to have it be, let's have it be parallel. So one of the ways of fixing the data wheel to the arm is to have the right datum planes of the arm be parallel to the right datum planes of the wheel. So let's turn on the datum planes, and then it's a little bit of a mess, but here's the wheel. Let's spin the wheel, and if I highlight this datum plane, this is the right datum plane of the wheel. Okay, now let's look at the arm. I highlight this datum plane. This is the top datum plane of the arm. Okay, so if I select the top datum plane of the arm with a left click, and then the right datum plane of the wheel with a left click, then the two are tied together and it gives me a status of fully constrained. Now this is flipped around from the way that I want it to be, so I go up and change the orientation of the constraint, and then it's where I want it to be. So let's click OK and then turn off the datum planes. Get this in a view where I can see it. Go up and drag components, click on the crank arm, and then good. The two components spin together so that we are ready for the next steps of the assembly.